Okay, so today we have a goal of I can multiply and divide rational expressions. Now today we're starting with multiplying and dividing. Tomorrow we'll look at adding and subtracting. So multiplying and dividing rational expressions. So first of all, let's again look at the steps. And remember what I told you? If in doubt, factor. And that is our first step. We need to factor both the numerator and the denominator. Now, these steps are for multiplying. When we do dividing, a few different things, a little bit different. We need to state our restrictions the same way as we did when we simplified. Then what we need to do, if possible, simplify before multiplying. So if we can simplify, we want to do that. Okay, now some of that when I talk about simplifying has to do with the fact that if I have 25 thirds multiplied by 27 fiftieths, what I can do is I'm not going to go 25 times 27. How many of us do that in our head? Well, I could, but I'm going to have a large number. So what I can do is I can do some canceling. 25 goes into itself once, it goes into 50 twice. The same thing with 3. It goes into itself once, it goes into 27 9 times. So really my answer is 9 halves. So much, much easier than literally going 25 times 7. So that is simplifying first. Okay, so then what we do is then we multiply the numerators and the denominators, just like I did with my example. I went 1 times 9 and then 1 times 2. After we do that, then we simplify. Okay, so in other words, we leave it in factored form and we restate any restrictions. Okay, so let's go and follow those steps and with some questions now. So one other important thing, now you saw me canceling to get that 9 halves, but it's important that you only do it a certain way. You can always cancel straight up and down. Okay, you can cancel sideways, okay, on an angle, either direction. You cannot, however, cancel this way, across. Okay, so it is either on an angle or straight up and down. Okay, examples, simplifying state restrictions. All right, the first one, factor. Well, nothing to be factored there. So step number 2 is state any restrictions. Well, the restrictions that we have here, 8 is fine. X cubed means that x cannot equal 0. Now I'm at step number 3, which means, if possible, simplify before multiplying. So what I'm going to do is I'm going to look straight up and down first of all, and if I do that, can I cancel this way? Well, not a x and 8. What about this way? Oh, yeah, I can. I have an x on the top and I have an x cubed on the bottom. So this will become x squared, and that x is gone. Then I look to see, can I cancel diagonally? Well, yes, I can. I have an x here. X goes into itself once. It goes into x squared once, so I have an x. So now what we're left with is some multiplying to go through. So we have 1 times 2y, so that's a 2y. Then we have 8 times x, which would be an 8x, and my restriction is x cannot equal 0. Okay, moving on to the next question. Okay, again, someone's been nice and has done some factoring for me. I'm going to go check and see, can I factor any more? It doesn't appear that I can. Okay, so I'm at the next step where I'm going to state my restrictions. Now the first one, b squared plus 1. Now that one, b can be anything, so any real number. There's the only way that that would equal 0 on the bottom there if b squared equals -1, which is impossible. However, on this one, however, b cannot equal 3. Okay, so again, everything's been factored for us. It's a matter of finding terms that belong together we can cancel. Now, although on the bottom here there isn't a bracket, that belongs together. The b squared is attached to the +1 through addition, so they have to go together. Now, if you look diagonally there, I have another bracket up here which is exactly the same, so I'm left with it just to the power of 1. Then if I go here, I'm left with b minus 3 and a b minus 3. Then I'm going to look and see what else do I have. Well, on the denominator I have a 5, but on the top I have nothing that goes with the 5, so I believe we are done. So now it's just a matter of multiplying. So here I have a 2a, and it gets multiplied by the b squared plus 1, and in the denominator I have the number 5. And finally I state my restrictions. Okay, and that's it for that page. And we'll go over to the next one. Okay, now when we're talking about dividing. Dividing, very similar to multiplying, other than, in a second, factor the numerator and denominator. Same thing. State restrictions. Reciprocate the divisor. So the one you're dividing, flip it around, reciprocate it, give it multiply by the reciprocal. But watch what happens here. Then state new restrictions. Because what happens is now when you reciprocate something, it's highly probable that you're going to have new restrictions going on. So make sure, oops, sorry about that. Make sure that you are actually stating any new restrictions. And finally, follow the multiplication steps. Okay, so there's a few extra steps here in the sense that we're stating restrictions both here, sorry, when I looked up here, went the wrong way, here and here. Okay, so we're stating restrictions twice. Okay, examples. Okay, the first one. All right, so it says factor. I can't factor, I'm done. All right, so now stating restrictions. Well, at the moment, when I look at my denominators, I have a 3 and I have a 12. There's nothing there that restricts t. So the next step I'm going to do is I'm going to reciprocate the divisor, so I end up with negative 20t over 3 times 12 over 4t cubed. Now what I need to do is I need to again look at my denominators. Do I have created any new restrictions? Yes, I do. Now what's happened is t cannot equal 0. Okay, so it created that here, that now t, if it's 0, is going to make my denominator equal 0. So now it's just a matter of canceling the same way as we did when we did multiplying. Okay, so lots of different ways you can do this. I see 3 goes in itself once, 3 goes into 12 4 times, and I'm going to continue with that 4. 4 goes into itself once, 4 goes into itself once. Now I'm left with, on the denominator, I'm left with t's. I have t cubed. On the top, I have a negative 20t. So this is going to be a t squared, and that gets rid of that t. So I believe that I've got everything that can be canceled. Now, if I happen to miss something, on the next step, I would be able to see it, and then I could make my correction. So I have negative 20, and if I look across the top, everything else appears to be canceled out. On the bottom, I have 1 times 1t squared, so I have a t squared. And again, I state my restrictions. So after I multiply, if I still notice that there's a factor between the numerator and denominator, I can actually cancel that out at that time as well. Okay, I believe this is our last question. Okay, what's different about this? It's longer. There's multiplying and there's dividing going on. So the same thing applies. We're going to factor. So my numerator here, x plus 7, is going to stay the way it is. I'm going to put a bracket around it because x is attached to the 7 by adding. So in order to get rid of that, I have to take the plus 7 with me. Okay, on the bottom here, it could be a perfect square, but when I take 6 times 2, I should have a negative 12x. I have a 5. So I need 2 numbers that multiply to give me 30. Subtract to give me 5. The largest one is negative. Okay, and I believe we can look at what? 9 times 4. So we have 9. Oops, better use something's not going to disappear. 9 times 4 is 36. 9 is larger. And here's our x and our x. And then we go over to here, and two numbers that multiply to give me 54, and they add to give me negative 15. So both brackets are negative. 54. So the most common multiplication fact for 54 in my brain is 9 times 6. Does 9 plus 6 equal 15? Yes, it does. So we have 9 and a 6. The bottom is a difference of squares, so we have an x plus 6 and an x minus 6. Then we go over to the next one, which is dividing, and you have to put the dividing. You can't flip it. I realize it creates a lot of extra work, but still have to do it. So two numbers that multiply to give me 63 and subtract to give me 2. Again, the most common multiplication fact I can think of for 63 is 7 times 9. If I subtract them, I do get 2. So 9 is the biggest one, so it becomes negative. And on the bottom, I'm going to put a bracket around the x plus 4 because x is attached to 4 through addition. So now what we need to do is we need to literally go along the bottom of the denominator and find all the things x cannot equal in order to keep the denominator away from 0. So x cannot equal. We have a negative 4, a positive 9, and a plus or minus 6. So that's not too bad. That doesn't look like a plus or minus, so I'll just plus or minus 6. Okay, so the next step is I'm supposed to reciprocate the divisor. So that's the next thing I'm going to do. So yes, you have to recopy it all out again. And you're saying that's a real pain. Yes, it is, but it's an easy pain. Some pains are harder than others. So here we go. And times x plus 4, and then an x plus 7, and an x minus 9. Now, when I flipped that, I created some new restrictions on the denominator. So now when I go and look at this here that was the numerator is now the denominator, you can see x cannot equal 7 or positive 9, but we have positive 9 before, so we have a new restriction that x cannot equal a negative 7. So now we get to the fun part where we can actually start doing a whole lot of canceling. And although there are 3, I can go x plus 7, and I can get this x plus 7 from the denominator from the third rational expression. Okay, so now it's just a matter of keep going and canceling, and x minus 6, x minus 6, x minus 9, x minus 9, x plus 4, x plus 4, and it looks like I'm done. Okay, so now I go and I see what I have left. On the top, everything's been canceled, so those have all been canceled to 1s. On the bottom, nothing left from the first rational. Second rational has an x plus 6, and the last rational has an x minus 9. And we finish off by getting all of our restrictions. Now make sure when you're getting all your restrictions that you're getting both the original ones before we reciprocated. So we have a negative 4, a negative 6, a negative 7, a negative plus or minus 6, and a negative 7. I think I have all of those now. Okay, so that gives you an idea of what you're expected to do here. This is the easier part when we get to multiplying and, adding and subtracting. You'll have, we have to work with common denominators. Okay, have fun.